PHY-layer spectrum sensing. Spectrum sensing is a necessary technology of cognitive radio. With efficient spectrum sensing, the spectrum opportunities could be discovered. From PHY-layer view, the spectrum sensing can be divided into three categories: non-coherent detection, coherent detection and feature detection, Sahai et al., 2004. The most usual non-coherent detection method is energy detection. The advantages of energy detection are short sensing time and low complexity. In addition, it does not need any a prior information. However, because of the uncertainty of noise, there exists a SNR wall. The signal cannot be detected if its SNR is lower than the SNR wall. As the signal is detected according to the signal strength, it cannot distinguish different kinds of signal. When the signal has the corresponding pilot, the coherent detection can be adopted. The matched filter is one of the coherent detection methods, but the performance is affected by high complexity, unstable time clock and the length of pilot. Because of these factors, the implement is limited in practice. Feature detection utilizes the properties of signal to detect whether there is any primary user nearby. As the signal has periodic features because of frame structures but the noise does not have any period, cyclostationary detection can be used to distinguish the signal and the noise. Using pattern recognition, different kinds of signal can be distinguished by comparing the cyclostationary properties of the detected signal with a prior known signal properties. Although the performance is better than energy detection, the SNR wall still exists. If the signal strength is not too low, the signal can be recognized from the unstable noise. MAC layer spectrum sensing. On spectrum sensing, there exists a trade-off between sensing time and sensing veracity. The sensing methods which have high veracity always need long sensing time. A two-level spectrum structure is proposed in IEEE 802.22, 2006, to balance the trade-off between these two aspects. Energy detection is adopted to discover primary users cursorily. Then, if it is possible that there exists any primary user, more elaborate spectrum sensing is deployed. Because of the fading effect, the spectrum sensing results of one user is not always accurate. Therefore, the cooperation between secondary users is necessary. Mishra et al., 2006. There are two kinds of cooperation: centralized cooperative spectrum sensing and distributed cooperative spectrum sensing. In centralized cooperative spectrum sensing, a centralized controller collects the sensing results from different users, and fuses the collected data all together to obtain a table for available spectra. The results obtained by centralized cooperative spectrum sensing are accurate relatively, but it needs long sensing time, large computational capability and heave overhead. Distributed cooperative spectrum sensing lets each user detect the signal and obtain the table of available spectrum respectively. By communicating with the neighbor users, the chosen spectrum is determined. How to sense the spectrum accurately by exchanging limited information is still an open problem.